Құрметті көрермендер, бүгін біз басқа Каспий деңгейінен 25 минут ғылыми подкастымызды бастаймыз. Біздің қонағымыз бүгін Мұстафа Кемал Гөнеш бей. Атырауға қош келдіңіздер.
Hoş bulduk. Welcome.
So, dear guest, today in our podcast, we would discuss about the green chemistry to make the chemical chemical reactions more sustainable for the future. So, maybe it's a great moment to see today Professor Mustafa Kemal Gümüş from Artvin Koro University in Turkey, and he is specialized in green chemistry and especially in microwave assistant chemistry. But today we talk about why the green chemistry getting more and more popular. So my first question, please just briefly explain what is a classical chemical synthesis, like when we use a lot of hydrocarbon solvents, so often they are very high point boiling.
Yes.
When then we have to make a lot of procedures for purification and so on. Well, what is that?
Yes. Yes. Thank you very much. I am very happy to be here. Yes. My name is Mustafa Kemal Gümüş from Artvin Koro University from Turkey. Yes, I am associated professor in chemistry department in Artvin Koro University. Also, I am manager of research center of our university. Yes, about chemistry, especially classical chemical synthesis. In classical chemical synthesis, generally chemists use hydrocarbon-based solvents, and these solvents can be, let's say, like hexane or toluene or
Aromatic.
yes, aromatic sounds. Yes, some aromatic it can be, also some aliphatic and cycloalkane can be also. For this solvent generally using for solubility of reactants, and also they use they are using for to reach high temperature to make higher speed, more speed, more fast reactions. But for this classical organic chemistry reaction for synthesis, for this solvents, when you use these solvents after the reactions, there is a main problem. If their boiling point high, you cannot totally take them with products.
So it's difficult to purify clearly from one substance from solvents.
Yes, this is yes, you are right. One of the main problem this one a bit to purification. Another problem also because of the product and solvents chemical nature, it can be even in crystal, it can be inside of solvent, and this there is also generally in reactions there is also some trace of water can stay also in product. sometimes for this solvent in this solvent to take trace of water, you can use another different method. Let's say molecular sieve or like some kind of distillation. You can see these two problems make challenge for reactions.
They also evaporate
Yes, yes.
like normally.
Yes.
I remember from my student
Yes.
area when I was a student, so we
Yes.
stay in the lab in a mask because it's all aromatics, very
Yes.
dangerous
Yes.
and harmful for human body and so on.
Yes, you are right. One of the what you are pointed, one of the main problem also health risk. Because of them, this solvents when you use, even they have higher boiling point, they are somehow, of course, evaporate and make someone also quite toxic. Some of, and it can affect health problem for people, also for nature, for outside. That's why better to green chemistry focusing generally more more green, more healthy solution for all for chemistry, especially one of solvent. They are they are searching more green solvent, more let like water or alcohol style or some extra solvent they are searching.
Okay, so the green chemistry, sure, the more has a less impact, ecological impact on the nature and surrounding and the people around. But another question, what is so the classical chemistry, especially in industrial level, optimized for some financial sustainability, for some income getting from this synthesis. So it means so the classical chemistry more or less financially stable concerning to get income for companies. How the green chemistry could prevail and be cost effective, more cost effective than classical? Is it possible or not?
Yes. Normally, is it possible? Of course. This is also classical chemistry. Also start 200 years ago almost, and make and when it started, it was more cost to be. But after you many research, people find
By
less,
optimizing.
yes, optimize. Also, green chemistry need this one too. If you optimize green way, and you always you can, especially with chemical engineer and chemist can work together. They are finding more green, more and more cheap way, and this last 20 30 years, maybe 40 years ago it started, and now most of procedure is become more green and more cheap. First of course, when you start first, it can be more effective. But if you look in long time term, it can be more economical. Let's say, for example, I I know some in Turkey, some candy product'tır. And ve 20 years ago they
Turkey
are
candy delicious.
they are heating sugar to make caramelization.
Yeah.
They are heating with electricity with copper pipe. Now
Flowing.
yes, flowing system. But now they change it maybe and they are heating sugars with microwave and it is maybe 100 times more cheaper than previous time. This is the depend of also looking and making new strategy and more cheap strategy. You can find.
Oh, that's a very good example. Yeah.
Yes. Even let's say also food industry there is also some sausage salams make individual packing and now for little things they are cutting with sono rolls.
Not by knife.
Not by knife. It is more clear, more effective and more cheap.
No pollution.
Yes.
By,
Yes.
Yeah,
This
microbes.
yes. There is several examples you can find for and cheap and green solution if you focus
Without
about
waste, without
yes.
because in knife anyway there is some waste when you cut in the knife, some traces
Yes.
remain in the knife. Yeah,
Yes.
very good.
There is also examples for chemistry also. Let's say for especially for microwave synthesis, even water if you have a in vacuum in pressure and high temperature behavior not water. I published several syntheses in water aqua medium and look like impossible normal reaction outside, but if in reactor if you
under excessive pressure,
excessive pressure their behavior change look like solvent. Organic solvents can solve in this area, so starting material and make product.
But before the classical, this reaction happens in hydrocarbon solvents.
Yes, it normally in literature in hydrocarbon is possible, but with microreactor with green more in green in let's say in not open in vial it can be reaction also.
And just because I'm chemical engineer, I know there's a most part of the price for chemicals actually comes from not from reaction but usually from purification.
Yes.
So it may be more cost effective reducing the price for purification using very clean solvents of ecological friendly solvents like water, alcohol and so on. Okay, let's discuss about 21st century and everything. Everyone speak about artificial intelligence.
Yes.
So let us try to discuss about what is the influence of IT, artificial intelligence could be to sustainable green chemistry or biotechnology. What can you say about this?
Yes. In my opinion, this is also a very interesting question. Now, almost all people and all scientists focusing about this topic. And also for chemists, for us, also this artificial intelligence also very useful because of you can normally normal you can search some it when I was especially students we are searching not with computer, we are searching science from chemical abstract. Now over time after we can search now we are searching with science finder to and science finder help also us how you can make reactions.
I remember from my young the chemical abstract.
Yes.
It was such a huge font book, and
Yes.
then you look in number, and then from the
Yes,
number,
yes, yes.
yeah.
I also when I was my master time 2000 it was I start masters in 2000 almost 24 years ago, and I searched almost 1 week and some result I found now with one click in 1
You
minute
get, yeah.
yes in 1 minute you can
1 second.
yes and let's say if artificial intelligence it will be more fast and also more they more recommendation and now people can now we don't we will focus for to choose this one and combine in the future it will be this one. And about artificial intelligence AI also very quite important for especially to find new and to find new method because of people's knowledge is unlimited and that one is not limited and if you compare combination artificial and people scientific knowledge it get be more better. Last month I was in Vienna for American Chemical Society conference. It was catalytic organic chemistry conference. Also this topic was also very popular in top of scientists. They say they are saying it will be in future it great impact for chemical chemistry application.
What do you think? Can artificial intelligence predict new chemical reactions?
Yes, they can predict.
So for people, we need only to check experimentally.
Yes,
It happened or not.
of course.
That's all.
And now also people, let's say, in drug development also very important because of
Complicated
this
molecules.
this complicated molecule also before last checking last experiment before experiment you can predict if it is possible or not, and you can also predict with target molecules, target proteins. After if it is good you can do reaction. This is also important.
Can artificial intelligence predict conditions for
Yes.
reaction?
Yes. You can do everything as I understand before, especially to make real experiment.
Because in human intelligence you can imagine the chemical reaction,
Yes.
but the question of conditions is another problem because you have to optimize the process, checking any conditions, varying them to determine the optimal.
Yes, you are right.
Oh, it saves a lot of time.
Yes,
by the way.
yes, it saves a lot of times, a lot of effort, and new impact. People say artificial when artificial intelligence come, people lost their work. They think, and now there is a bit negative look. But in my opinion, all new things open more new doors. This is if you think, if you say, if you check from history, this is like this. Of course, people, humanity always going in front, and this is also one of the humans new idea, and it will be good, I think, in future with chemistry. Not
Thank
only
you, fantastical. So the traditionally our last question, just for looking a little bit ahead in the future. So what do you think the most breakthrough or emerging trends now in green chemistry? It's what is it? It's a supercritical CO2 or microwave assisted reaction or anything else? What do you think?
First of all, especially I wanna talk about not about your question, a bit
Okay,
more expand,
okay.
because of especially with now new trend or new focusing is more environmental and sustainability, not only chemistry, for life and for lifestyles. Especially now because of the too many pollution, European Union, in USA, and also without global organization is focusing more sustainable and green solution for human lifestyle. That's why in chemistry, for green chemistry, and there is in European Union they say Green Deal. And we are let's say we are in Turkey is near to Europe. We are also following European Union rules the most because of USA a bit far or something. That's why we are following or recommending. We are very near with European Union, and for green looking is affect everything. And in chemistry, it starts with green chemistry, but now green engineering also popular. Green chemistry engineering, I mean, or green architecture also popular. Now is green not only color, also is lifestyle. And for last question, for this green solutions, governments, European Union or EPA is have too many opportunity to make new project. That's why this is for green chemists. This is also important to make new project and expand green chemistry. For this one, in my opinion, in future it will be flow chemistry. For green chemistry, flow chemistry is affecting, making too much because of in flow chemistry, little pipe, and in 1 second reactions in molecule is making not in pot, and it will be in future of for, in my opinion, maybe I am wrong, it will be flow chemistry.
Because the possibility of contact between two different molecules
Yes.
higher than in a pot.
Yes, yes.
Yeah, yeah.
It's in very
And
narrow
in the,
area
yeah,
and touch each other, and in one
Micro-
second, less than
microfluidic.
yes, yes.
Mhm.
It will be this one. It can be.
But in big industry scale chemistry, what do you think? Because I'm from petrochemistry, so the one of the main problem for us is the CO2 emission.
Yes.
So what do you think, like liquid supercritical CO2, it could be possible use as a solvent in industrial scale or not?
Now already there are some of let's say caffeine extraction. Let's say they are
They
also
use
using for
CO2.
industrial scale.
Oh.
This is carbon.
You know about coffee, because
Yes,
you're from
yes,
Turkey.
yes, anything. But you can use carbon dioxide. Now one of the popular topic is carbon capture.
Yeah, I know, because
Yes,
this
when
is
you are-
one of the
yes.
main headache in petrochemistry.
Yes, yes, yes. From carbon capture from atmosphere. I
Mhm.
mean, if you maybe in future if we will finish our fuel in underground, we will focus to take carbon from atmosphere and use this one. This is also possibility, not only solvent, for everything. Carbon is main element for life.
Yeah, sure.
For life, that's why is carbon important. That's why if people utilize capture carbon and utilize what they want from, let's say from carbon dioxide solvent, also from carbon dioxide to make carbon bond and carbon skeleton.
Okay, thank you very much for such a nice discussion about green chemistry and about the future of chemistry to be more sustainable in sustainable world. Thank you very much.
Thank you.
Mustafa Bey, teşekkür ederim.
Hürmetler diliyorum. Ben teşekkür ederim.
Құрметті көрермендер, басқа hafta кездесеміз.
Görüşürüz.